y equals the absolute value of x is what we refer to as the parent function. So y equals the absolute value of x is the parent function. So y equals the absolute value of x plus 9 is a transformation of that parent function. The plus 9 is inside. So a positive 9 inside does what to my graph?
It moves the graph left 9 points.
Perfect. So it's going to go left. In what direction? So now we are on the inside again, but inside the graph, it is now a negative instead of a positive. So if it is a negative instead of a positive inside that graph, if the positive 9 inside moves me left 9, a negative 8 inside moves my graph what direction? Do you have your homework and stuff for me? I'll come get it. Perfect. Who said right? Awesome. And it's going to go right how many? Great. All right. Now, number 3 has 2 differences from the parent function. We have a negative 2 and a positive 4. So Alexis, go ahead and pick on somebody to tell me what that negative 2 does to my graph. Perfect. So that negative 2 will move me right 2. The positive 4 on the outside moves me up 4. Without graphing, who can tell me what my range would be for number 3? Go ahead, Jesse. Perfect. Y is greater than or equal to 4. Okay, number 4. In example number 4, we have multiple transformations. So we have a negative in front. So what does a negative in front do to my graph? Reflect it. The 3 in front of that function is going to change my slope, and that 3 is greater than 1. So a greater than 1a value is going to do what to my graph? Stretch. So it's going to make it much more narrow. And then inside, I have a negative 5. So a negative 5 on the inside shifts my graph right. And a negative 11 outside moves my graph what way? Now this graph, because it's reflected, does what to my range? Sophia? Yeah, instead of being greater than, it's now less than. And what number is it going to be less than or equal to? Negative 11. Okay, taking those ideas and concepts, apply them to that last example. Yes, the slope check his homework before I forgot. Gross. All right, number 5. All right, as a group, as cohesively as possible, what does a negative do to the graph? The 1/7 is going to do what to the graph? A positive 7 moves my graph in what direction? All right, -5 pushes my graph where? So, the slope is different than just the A with the compressing and reflecting in the sense that the slope includes both values. So my slope is what? So my slope is -1/7. So it's going exactly down 1 and right 7. What is my vertex? Oh, so it's -7, -5 because it's left 7, down 5. And what is my range? So because it's reflected, my y values are less. Yes. Then the reflection, that's a good question, comes from the negative in front. Oh. I didn't do that. I don't know why I did that. What? No. They're symmetric. And then can you take your sunglasses off? Because I would be against our dress code and I don't want to get yelled at. And I feel like... Thank you. So symmetric is with respect, like the vertex points. You apply your slope. So like if I were to graph this, it would go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Like it would be here. The symmetric aspect says that it goes down 1 and over 7 to the right. But because it's symmetric, it also goes down 1 and the opposite direction 7 to the left. So the symmetric comes from the vertex. The reflection comes from the fact that this graph opens down as opposed to opening up. If it was a positive 1/7, those points would have gone up 1 and left 7. All right, so let's do one last review together as a group. So once again, we have a graph that has multiple transformations. And my goal was to actually have you guys write on there, but for whatever reason, the Zoom is not allowing writing. Maybe I'll leave and come back. All right, so I did not have you guys create a table. It used to actually have the students create tables. I think that we're perfectly capable of graphing these without a table, so you could actually put a little line through those tables. I am not having you make tables. Nope. Okay. So if you look at this graph, you have 2x minus 4 minus 2. let's just go through all of our key points, and we're going to just popcorn through it. So who wants to start? You don't know what my question is. All right, Alexis, thank you. So, Alexis, what does the positive 2 in front tell me? That's great. My slope is 2. Okay. What is my vertex? Who wants to tell us what the vertex is? Alexis, you can popcorn or pick a raised hand. Perfect. My vertex is 4, negative 2. Good, Leanna. Pick someone else. I didn't say it. All right. Chris, what does the negative 2 at the end of the absolute value equation, what does that negative 2 tell me? What direction is this graph going? All right, perfect. It is going down 2. Okay, Chris, pick someone. Okay, Nick, the negative 4 inside my absolute value. What direction does that move my graph? Perfect. Okay, pick someone, Nick. Will, what is the domain? Okay, Will, pick someone. Jesse, what's my range? Careful, it's open up because there's no reflection. All right, we talked about the slope. Pick on someone. Okay, Dylan, we talked about the slope being 2. What's that going to do to my graph? Stretch it or compress it? Perfect. All right, let's plot our points. So we're going to plot the point 4, negative 2. My slope is 2. Don't pick on someone. Calvin, if my slope is positive 2, what is one other point I'm going to graph? Give me the ordered pair. So my vertex is at 4, negative 2. My slope is 2. What's the next point I'm going to plot? Perfect. My graph is symmetric. Calvin, pick on someone. The graph is symmetric. If I plotted 5, 0, what other point am I going to plot using symmetry? Okay, careful. That would be if we were graphing a line. So if we're graphing an absolute value, instead of going to 3, negative 4, we're going to go to 3, 0, because we want that V. Okay, on our quiz, I need 5 points from you. So this is 3 of them. You're going to take your slope again, go up to right 1 from 5, 0, and go up to left 1 from 3, 0. So you're also going to plot the point 6, 2, and 2, 2. Connect your dots. I know, saying 2, 2 is funny. And then there's your graph. Yes?
So, like, if we're doing the test and we don't plot them 5 points, is it like minus 40 or something?
All right. Down at the bottom. So who did I leave off with? Philip. Pick on someone. Whoa. All right, what happens to the vertex in this example here? So it's f of x equals absolute value x plus 6. What happens to my vertex if it's a plus 6 inside? What direction are we going? How many? Thanks, Alexis. I could see her pointing. All right, Hunter, pick on someone. Right behind you. Yep. Perfect. So, in summary, a number is inside of the absolute value bars. The vertex is going to shift left or right. And it goes left if the H value is positive. And it goes right if what's inside the absolute value is negative. Yes. Yes. And you might have to point to my board so I understand completely. All right, Lauren, next up. All right, Van, a negative 2 after the absolute value does what to my graph? Perfect. Next. Quite a few still. Okay, a positive 6 after the absolute value does what, Sophia? Perfect. So in general, when a number is outside the absolute value bars, then the vertex shifts up or down. And piecewise. All right, Sophia. Jacqueline? All right, Jacqueline, a 3 in front of the absolute value is going to do what to my graph? It's not going to go up 3 because that's the number after the absolute value. So the number being multiplied. I think we're kind of use this idea up here. The 2 is in front. It did what? Yeah, so a 3 in front is going to make my graph narrow. It's going to stretch it because A is greater than 1. Okay, go ahead, Jacqueline, pick on someone. Sam. The 1/2 does what? Perfect. Because my A is between 0 and 1. So when a number is multiplied by x, the absolute value function is going to stretch or compress. Don't think this is where you were asking me, but maybe. A negative. Sam, pick on someone. Yes, it does. That's what I thought. So a negative in front of the graph reflects it. So that means it opens down. The negative 2 here reflects it, so it opens down and moves it down too. So when there is a negative sign outside of the absolute value function, it reflects across x. All right, my dear ladies and gentlemen, that next page is your homework. However, you are only doing the odds. No, it's like the whole, odds, multiple, to the end of the packet odds.